Hello, everyone. Thank you very much for being here today. In the next 35 minutes, we're going to talk a little bit about Kubernetes security and what we learned at ARMO from scanning over 10,000 clusters. And I say a little bit because Kubernetes security is a serious thing, and we probably won't be able to take it all in 35 minutes, but I am going to do my best. So, a little bit about myself. My name is Gal. I'm a product manager at ARMO. ARMO is a Kubernetes security company, and we are proud to be the creators and the main maintainers of Kubescape. And Kubescape is an open source project. It was donated to CNCF about 6 months ago. I'm a former DevOps engineer. And actually, this is my first time presenting here in ContainerDays. So if you don't mind, the next slide will show you why I want to have a selfie with you. And if you could please all smile, a big, big smile, like this, like the man on the left. And this is also a souvenir for myself from this talk. So, because we're working very hard on Kubernetes security, we've learned so much, and we thought that this information should be shared with you guys. And I'm lucky to be here today and giving you this information. So we're going to talk about what we've learned from scanning 10,000 clusters and some more registries and repositories, and we will compare the security of open source projects and the general populations projects and the security posture of both. And looking at the person on the left, take a good look at him. That's what happens to you before you hear about cybersecurity specifically in Kubernetes. And after you hear about cybersecurity in Kubernetes, you turn to the right guy on the screen. You start getting all suspicious about everyone. It's like your partner asks you, how was work today? And all you can think about is, does she have my Kubernetes secrets? Does she have my cloud credentials? It's like you get all paranoid. And this is not that kind of a talk. We're going to end, hopefully, with a good note. So keep that in mind. Let's set the starting point. We'll talk about a little bit about Kubescape. And as I said, Kubescape is an open source project under the CNCF umbrella. And we've developed Kubescape when we had in mind that the industry needs a security posture tool. So something that you can use in order to scan your clusters, your environments, your images, your repositories, and get a report on what you should do and what is your current security posture. So we try to answer two main questions. How secured am I? And what should I do in order to improve my security posture? So Kubescape can scan and find misconfigurations, can find vulnerabilities inside your Kubernetes level, at the Kubernetes level, and also in the workloads level. So we're talking about misconfigurations, and we're also talking about the images that are configured in those deployments. So we created Kubescape, and at ARMO, we are getting a lot of security posture reports. So we tried again, we took that information and we tried to make it normalized in order to show it here today. So what we do at ARMO, we take all this information and we store it for the users. ARMO is a SaaS platform, so this is where you can get the most up-to-date information about your clusters, about your environments. And it's amazing because we store it, right? Storing is amazing. But what we say is, don't let your information just sit there and be stored. Use it. And if you're using it, use it for good. So we took our own advice, because it's a damn good one, and we created this presentation. So like I said, Kubescape scans for clusters, repositories, YAML files, images, inside your clusters, outside your clusters, and this data is all uploaded to our platform. setting the ground, a little glimpse of what the information looks like. So we took this information. This was the foundation for our research. So we freeze the data a couple months ago, where we had about 17,000 clusters scanned, over 40 million objects, almost 180 registries, thousands of repositories, and this is the information that I'm going to share with you today. So now that we set the starting point, we set the grounds, we are going to have two parts for this talk. The first part is going to be about misconfigurations, and the second part is going to be about image vulnerabilities. So, like we said, we're going to compare two parts, two data sets. We're going to compare the general population project and the CNCF graduated project. And as to why we decided to go for the CNCF graduated project, it's because they have better quality control, they have better regulations, and they should be very compliant and very secured. So right here, I just wanted to mention a few definitions that we're going to use across this talk. So we are going to use controls, and controls are tests. They are single tests used by Kubescape to evaluate, meaning let's take, for instance, a privileged workload. If there's a privileged workload, it will fail on a control that tests for privileged workloads, and it will pass on workloads that are non-privileged. A framework, this is a group of controls. So, for example, we took the NSA and the MITRE guidelines, we translated them into controls, into single controls that can be evaluated. We have the CIS, the NSA, the MITRE, and some more frameworks that we created ourselves, like DevOps Best and the ARMO Best frameworks. So, just a sec. So, what we did at the beginning, the first thing that we did is we took the compliancy frameworks and we tried to check which framework is being, let's say, being complied to more. So from this graph, you can see that the NSA and the CISA frameworks are a little bit harder to be complied with. The bigger the number, the better. Because if the number is big, that means that if the percentage is closer to 100, then you're more compliant with that framework. So the NSA and the CISA are harder to be complied with. They're not hard to be complied because they are hard guidelines, rather because it's hard to implement in your environment. And we will talk about it in the next few slides. So let's look at the controls level. This is the general populations project. And the first thing that you can see right here is that we count each control and how many times it failed. So the highest one that you can see in this presentation is the immutable root file system. That's the highest one that we see that has failed on clusters and misconfigurations at customers' environments. And you can see that the first four are pretty much in the same count. And then we can see some kind of a drop. And this actually means that approximately the same number of privileged workloads has the same number of immutable root file system. Exactly, probably the same. It's about 100,000, so we found that the numbers are pretty much the same. Comparing to the graduated project, we can see that the same controls moved a little to the back. So for instance, we had the first control, which was mutable file system, and non-root containers, which was the second, if I remember correctly. So they did move a little back. And this is interesting because it actually means that those projects, the graduated projects, look a bit different from what we see in the general population. And talking about specific controls, you can see the numbers right here. This is, again, the general sample, the general population sample, and the graduated project sample. So I don't know if you know, and if you don't know, I'm not going to tell anyone, but it is not recommended to run workloads as root unless you really, really, really need it. So if you look at those numbers, you can see that 91% of the general population projects are actually running containers as root. And it's not very far behind for the graduated project. It's a bit better, but it's not a huge difference. So what we've learned is that there's no vulnerability. If there's no vulnerability in the Linux kernel, then there's no difference whether you're running as root or not, because it's less exploitable. And comparing the immutable file system that we talked about, actually, these are, as you can see, pretty close numbers. So again, if you don't know, I'm not going to tell anyone. It's a good practice to have your containers run with read-only, so you can protect more sensitive areas in your file system. And it's not an easy task to do, and this is why a lot of misconfigurations are found in this specific domain, because it's not easy to define, it's not easy to implement, and we know it, but these are the numbers as we saw it. Looking at this control, the credentials everywhere, so we are talking about disabling the automatic mapping of service account token failures. It's kind of interesting because this is a Kubernetes control, and Kubernetes is mapping a default service account token for every container. So these numbers actually mean that users are not really changing the behavior of the default Kubernetes behavior. So you can see that 81% of the general population doesn't even disable that. In the graduated projects, we have a bit better numbers. One more control that we can see is the apply security context. And this is, again, interesting because you can use different context implementations to change the default user ID, the group's IDs. You can disable privilege escalation from there. You can add SecCom profiles. So if an attacker does get any access to your environment, he can't do too much if you apply these principles and context. So you can see, again, the percentage right here. Actually, we thought that the general population sample would be much higher. So it was a great surprise for us, a very good surprise for us to see that the numbers are not 100%. And we like those numbers. And again, here you can see that the graduated projects have a better number than a much better number than the general population. And comparing all the controls together, you can see that there's not a big difference between the general population samples and the graduated projects. It's 38 to 35%, and that means that there's a very slight difference, and it's in favor of the graduated projects again. So this was the part where I'm talking about the misconfigurations. And now that we covered that part, we're going to move to the second part, which is talking about, like I said, vulnerabilities and images. And in vulnerabilities and images, we did the same thing. We compared, we reviewed, and we used something called relevancy, which I will talk about in a minute. So what you can see here on screen, these are the most scanned repos, image repos. So you can see Argo CD, you can see Redis, Prometheus, you can see Mongo, and these are the general population. If we go to the graduated project, the numbers doesn't change dramatically. The list doesn't change dramatically. So again, we scanned all those images, and we compared the two samples. So what we found is that you have a higher probability of having a critical vulnerability in your image in the graduated project. Now, that's a very interesting topic, and we will touch it in a few seconds, in a few minutes, and you will understand why it's not that surprising. So we took the list of the top vulnerabilities that we found in the general population, and this was the next step. We tried to find all the juicy information. We tried to find all the things that we want to publish out. Like I said, if you have data, then use it. Don't just let it be stored. And this is the most common vulnerability that we found, again, in the general population. And this is a BusyBox vulnerability. And we all know how sensitive you are to your terminal's colors, right? That's one of the main things that you do in your new job. You go and you just configure your terminal's colors. So using this vulnerability, the attacker can change your terminal color. That's crazy. So as to our experts say, this is not a very common scenario where a victim is opening a shell inside a container, and then the attacker comes and he does send some crafted shell commands. So it's not really exploitable. Or it is exploitable, but very hard to exploit. This is the second vulnerability that we found, which is used in so many containers, because I believe that over 98% of the containers are using the libgcrypt in package installations. But if if you're not installing anything during the runtime of your containers, then there's no real risk. And again, this is the second most highest vulnerability that we found. The next one is a SQL attack. If the application uses SQLite, then it might get exploited. Again, very hard to exploit in real time. So what we did, as you saw the list a few slides back, we turned the most vulnerabilities that are really exploitable. We filtered the most vulnerabilities that are really exploitable in your cloud environment. And you can see that we are down to 2 vulnerabilities. And this is, again, the public, the general population in the public of open source. Again, moving to the graduated projects, we did the same thing. We took the vulnerabilities from those images, and we started looking at them. So we found that this vulnerability is the #1 vulnerability. And this is a very strange vulnerability, because what we found is this is not a vulnerability. This is a bug in the vulnerability scanner. And that's a misidentification of a software package. And this is the highest. So again, after we took the list down, we filtered the list down, you can see that there are a bit more vulnerabilities in the graduated projects that are more relevant in your environment, but we will talk about relevancy in a second. So remember the graph from before where we saw that the critical was very high for the graduated project. This is the same graph, taking everything together, counting how many vulnerabilities in every image. So you can see that the general population samples have much more vulnerabilities. And if we're thinking about taking a random image from the general population, consider taking a graduated one before. So in terms of vulnerabilities, CNCF projects look much more secured. Good thing for you, CNCF. But a vulnerability that is being detected by the vulnerability scanner is not necessarily exploitable. So for this instance, we've created a feature inside Kubescape, and we found a way to filter out those vulnerabilities that cannot be exploited. And we call it relevancy. A vulnerability in an image doesn't necessarily mean that that vulnerability is exploited and the workload is being jeopardized. So what we are doing, we are identifying which packages are being loaded into memory at the container runtime, and which of the vulnerabilities just sit there because they're on the image itself. And a package that's being loaded into memory and is tied to a vulnerability is much more likely to be exploitable than an image that is not loaded, than a package that is not loaded into memory. So we are filtering all those packages, and what we found is that taking the relevancy and testing it, again, on many images and workloads, and comparing all those workloads and images, you can see that the before and after the filtering of the relevancy. So if we take, for instance, the Postgres, you can see that there's more than 1,000 vulnerabilities by default in that image. But running under the relevancy filter, you can see under 20% are really relevant. So we are talking about saving 80% of your time to work on that workload alone in order to fix those vulnerabilities that are not relevant for you. And if we're looking at the results of the relevancy filter on the two compared groups that we saw before, you can see now that most of the vulnerabilities in the general sample looks relevant, where in the graduated projects, most of the vulnerabilities are not really relevant. So actually, again, CNCF does a very good job with the graduated project, and there are less relevant vulnerabilities on those projects. So talking about why we decided to, again, to take the graduated projects is because most of the CNCF projects are written in Go, and they can run without any extensive base images, and they don't need any external libraries, many external libraries. So this is actually why we decided to use those images, because they are less likely, again, to be exploited. And I think that CNCF is making more effort in implementing more quality control and more regulations on those projects and those images to keep them even more secured. So they're doing a pretty good job with that. So to conclude the two parts that we just talked about, we talked about, again, the misconfigurations, as we talked about the vulnerability side. Graduated projects are less prone for vulnerabilities and misconfigurations for those reasons that we just mentioned. And vulnerability scanners are doing their best effort in scanning and showing you results. But actually, it's like having a million problems, thrown at you. So you don't really know what you can do with it. And the vulnerability scanners can't find 0 day, which is unknown vulnerabilities. So of course, you need to keep the numbers as low as possible, as you can, of course. And talking about the misconfigurations part, so the graduated projects did have a bit better output, since I think most of the projects are being maintained by Kubernetes, very experienced Kubernetes developers, and they can tweak the configurations. They know exactly what they need to do a bit better sometimes than the general population, but it's still far from perfect. So what I want to do now is, actually, I want to encourage you to improve your security posture, whether you are using Kubescape or any other project or tool in the market, because our goal as a company is to make the Kubernetes domain even more secured. And I hope this has been informative for you, and thank you very much for listening.
Cool, thank you. Thank you, Gal. Again, any questions you have, feel free to put them on Slido. So we've got one question, which is, which technologies did you use for the analytics process?
For the analytics process?
Yes.
This is a question I will have to take with the developers and the analytics team. If we're talking about the technology that is implemented behind the relevancy, then we are talking about eBPF. But specifically for the analytics, that's a question I can't answer right now.
I'm sure Gal will be more than happy to connect you with the right person within the Armo team. I'm
also going to be here for the next 2 days, so feel free to just jump and say hi, and we'll find how to answer those questions.
Cool, awesome. I think I have one question is, first thing to do, all right, brand new to security and Kubernetes, what is the one thing I definitely have to do? Top one thing, if you do have one.
I think that the first thing is to assess your security posture. You have to understand where you're located in the security posture, spectrum. You can use Kubescape or any other tool for that matter to understand what you need to do, how secure are you, and what you need to do in order to improve your security. I think because security is a very, very large domain, then you need to know a lot of things. But if you get the right instructions about what is the next step that you should do, then you don't have to do anything. You just have to read and learn from the tools that give you this information.
Cool, awesome. So basically, start off with where are you currently?
Yes, yeah.
And then move from there.
Yeah.
Awesome. Thanks a lot, Gal. Please, another round of applause for Gal.
Thank you very much. Enjoy your days.
Thank you. We now have a 30-minute... Oh, well, hello. I turn my back for 2 seconds and I get a few more questions. We do have time for the questions, so I'll actually go through them. Is the open source Kubespace providing the option to filter for relevant issues? Sorry. And does it help how to fix, example, config issues?
Yes. So Kubescape is the open source project, and we have two flavors of that project. You can use the CLI tool, which is Kubescape itself, and it doesn't have relevancy. But if you're using the Helm chart installation on your cluster, then we can monitor the eBPF probes, and then we can extract that information from runtime. So the Kubescape itself, no, but the Kubescape in the Helm chart, yes.
Okay, the questions are coming in.
Nice.
I'll go through a few more. Sorry. So, did you find that CNCF graduation projects had less vulnerabilities than CNCF incubation projects, or is this data recorded in the report?
Okay, so what we did is we took the graduated projects. We didn't test for the incubation projects, but it's a nice research to do.
Next step for your next
Probably.
10,000 clusters.
For 20,000.
So how do you decide which issues are relevant at your relevancy filter? Are the decisions explained? Excuse me.
Okay.
How do you keep false positives and false negatives down?
Okay, so part of what we're doing, we're taking the SBOM, which is the packages that are on the image itself, and then we are running the relevancy feature and scanning and listening to which packages are being loaded into memory. So we get a filtered list, filtered SBOM list. And when comparing those two lists, you get a very, very filtered list. Now, it depends on your company's policy. You can say that you are only fixing critical and high vulnerabilities that are relevant in your environment, because when you're running Postgres and I'm running Postgres, we are not running the same things inside Postgres. So it depends on the company's policy in general, but we give all the information so you can take that decision.
Cool. I think this one probably is relevant with what you've just said. Are your findings publicly available?
In the slide share, and when we share the recording from today.
Yep. So there you go. Are the vulnerabilities mostly caused by outdated base images, like end-of-life Debian, or outdated software from package repositories?
That's a very interesting question. I'll have to take that offline and check.
Yeah. Again. Feel free to contact Gal or anybody within the RMO team.
Yeah.
And then the last one is, are you storing my scans and can I opt out? I assume by scans they mean the cluster you've scanned.
Right. So we are storing your scans, but we remove all the PII information before it's being sent into our backend. So no sensitive information in the backend. We don't use your data. Like if you have medical data or something like that, then nothing is being sent into the backend. And yes, you can definitely opt out.
Cool. Thank you, Gael. Off to have coffee.